Hello and welcome back to Mr. Powers Teaches Algebra. So we are going to talk about today a little thing called factor by grouping. And so the last time I went over a little bit of factoring out greatest common factor. I didn't really mention that we're doing these in polynomials. This is a polynomial. All these guys are polynomials. And I have a definition right here of a polynomial in one variable at least. And it gives us a good idea of what it is. So polynomial in one variable is anything of the form a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus a sub n minus 2 times x to the n minus 2, so on and so forth till we get to just a times x, so plus ax plus a naught. A naught is just a constant. So we're saying a sub 1, a sub I, any of these a's, they're all real numbers, and n, so the powers on the variable, on the x's, powers on the variables, are non-negative integers. We could have more than one variable, same thing, all the exponents, the powers on the variables, the x, the y, the z, whatever they are, they have to be positive and or non-zero. So 0 is okay. And then the coefficients are real numbers. That's the idea. And here's a bunch of examples. Okay? So we are dealing with things like that. So let's go ahead and do some factoring by grouping. Okay, and I mentioned this too. We did, especially this one right here, a little factoring out greatest common factor. If we extend that, we get this factoring by grouping method. And I always consider there's lots of ways to factor when we get there, trinomials, quadratic equations, stuff like that. And there's real procedural ways, algorithmic ways to do it that are really long and boring, and then there's the more intuitive ways that anyone who knows how to do it and does it well does it with the intuitive way, the guess and check. And I always go back and forth which one to use. But anyway, right now, we're not quite there. What we're going to do is factor by grouping. So let's say I have something like this. I want to factor by grouping. So for example, there we go. Okay. Let's say we have an example, and we want to factor 3x squared minus 2x plus 12x minus 8. Now, and I mentioned it already, so sometimes we can force this situation to occur, and sometimes we're given situations where we have 4 terms. 1, 2, 3, 4. We have 4 terms, anything separated by a plus. 3x squared, negative 2x, plus 12x, minus 8. There's our 4 terms. And when we have 4 terms, what we can do is factor by grouping. Okay? We want to treat these, kind of want to break this up, the first 2 terms and the last 2. And kind of like, you know what, let's just pretend like we can factor those separately. Because we can. So let's see what happens when we do it. So when you have 4 terms, and that's the big thing to remember, is we do this method right here is when we have 4 terms. Okay, so the first 2 we group up, the second 2 we group up. Then we just do greatest common factor on each of the groups. So what's the greatest common factor between 3x squared and 2x? Well, they both have an x. So they both got an x, so I can say x. And 3 and 2, well, that's nothing in common, so that's it. All I can take out is an x. And if I do, what's left? I'll have a 3x here, because x times 3x is 3x squared. And then I have a negative 2 here, because 3 times negative 2 is negative 2x. Great. Then I got these 2. What can I factor out of there? So let's see, I did green on those. They don't both have a variable, so I can't do that. But they both do have numbers, 12 and 8, and both those are divisible by 4. So I think I'll factor out a 4. It's a positive 4, so I'm going to write plus 4, because, you know, we had this plus sign here. If it was a negative, I'd write -4. But I'm going to factor out +4. So +4. And what's left? 4 times 3x is 12x. 4 times -2 is -8. Okay, so I got it. Now that is a fascinating thing, because now if you look, what I've kind of done is, one way to look at this is, now that I took something that had 4 terms right here. This guy had 4 terms, right? But this guy, we could look at it almost like there's 2 terms now. 1 right here and 2. We kind of look at that. There's 2 terms. And what do those 2 terms have in common? What they have in common is this 3x plus 2. They both have that 3x plus 2 there. That is what's really, really neat. And that means I could factor that out. And some students have trouble factoring out a 3x plus 2, but they're out of both. We can factor it out of both of them. So if I factor that 3x plus 2 out of both, I get a 3x plus 2. I'm sorry, 3x minus 2. Okay, 3x minus 2. Factor that out. Well, 3x minus 2 times x, that was in this first term. So x is in there. And then 3x minus 2 times 4 was in the second term, so plus 4. And I am done. I have factored this 4-term polynomial into a product of 2 binomials. So I was able to factor it, and I can't factor these anymore. So I can't take anything out of the x plus 4. I can't take anything out of 3x minus 2. I can't rewrite this as a product of terms like these or other stuff. So that's done. All right, now just in case you had trouble with that, I want you to take this and just pretend like, I'm going to say, hey, let 3x minus 2 equal, let's say I'm going to make it equal u. If I did that, I would have x times u plus 4 times u, if I rewrote what I had right here. And then if I was going to factor this, what's the common factor? Well, I got a u in both terms. I could say, you know what? Then I got a u times x plus 4. And we can see that if we distributed this in, u times x is xu, and u times 4 is 4u. So that is perfectly right. And now if I wanted to go back and say, you know what? Let's change u back to 3x minus 2. I would get 3x minus 2 times x plus 4. Now, the reason I did this was just so you could see the similarity between what we did from here to here and what you do from here to here. It's the exact same. It's just we got this weird expression. This 3x minus 2 is a big expression, but we can treat it as a single factor and factor it out. Hopefully that makes that clear. And you can see how here this expression is the exact same as this one, except a u is in place of the x plus 4. So that's one example of factor by grouping, and they're all like that. They're all very, very similar. Okay? And that was 9 minutes. I think that's a long enough video explaining how to do that. So until next time, enjoy doing math. Well, you know what? I guess we can write some steps. Let's write some steps. Or at least talk about the steps again real quick one more time. First step, group the first 2 terms and last 2 terms together. Then the second step is each of those groups, factor out the greatest common factor. That was right here. Factor out the greatest common factor. Next, hopefully, if we can go further, what ends up happening is, you see it highlighted in yellow, we get a common factor. It's going to look weird, but there will be a common factor. And then the last term is factor that guy out. That's what we did. So that's a quick review. So hopefully that does it for you. And until next time, have fun doing math.